Hi, this is Joyce Magill, and I'm giving my lab report for Lab 3. And today we're going to be tracking the movement of a guy on a skateboard rolling down Skiles Walkway. So the first thing I did was I uploaded my video to Tracker. And let's see. Okay, here's our little guy on a skateboard. The first thing I did was I set the reference frame from 45 to 95. And then here's our little guy rolling along. So the next thing I did was I set the origin to approximately where his head is, the back of his head. Then I also set the calibration stick to be the size of his head. So after I set those, then I went ahead and I tracked him. As you can see here, the little dots follow him, which gave me this data here on the side. So I took the time and the X values and I made an Excel sheet to make a little chart out of it. Then after doing that, I went to VPython and I used this data to help me predict to predict the movement of the guy on the skateboard. So for our initial conditions, we have the mass. I used 77 kilograms because we assumed the mass of the man to be 75, the mass of the skateboard to be 2 kilograms, which gives us a total of 75. Then for vector 1, we're only moving in the x direction, so that data is given here in Tracker. Right here, x at time equals 0 is 31.25, which we have right here. And then to find the initial velocity, I used the change in x over the change in time. So 50 minus 31.25 divided by 0.033 minus 0 gives us approximately 568 meters per second. Then delta t is also given here in Tracker, which is 0.033 seconds. So after the initial data was set up, I came down here to the net force, which is 0, because we don't really know the force given of the pushes and pulls on the skateboard and the guy and the x direction, but because the object is moving at a constant speed, we know that the net force in the x direction is 0. So then the next thing I did was for this equation here, I used Newton's second law. Given here, I used this equation, final velocity equals initial velocity plus net force divided by mass times the change in time. And then here, to predict the new position, I used this last equation at the bottom, Rf equals Ri plus velocity times the change in time. So after setting all that up, we run this, and here's our graph. And I took that data and I put it into the Excel sheet, which is given here. So here you can see on the left is the Tracker data, which is the actual data, and on the right is the position, the predicted position by VPython. And then finally, for the what if question, if we move the origin to the left, for example, then our data points are going to be higher in value. And if we move the origin to the right, then our initial position is going to start at a negative number and increase from there. So again, I'm Joyce Magill, and this is my report for Lab 3, and thank you for your time.